Lines L1 and L2 have vector equations here and here, respectively. The point A has coordinates minus 3, 0, 6 relative to the origin O. Show that A lies on L1 and that OA is perpendicular to L1. Show that the line through O and A intersects L2. Given that the point of intersection in part 2 is B, find the ratio of OA to BA. Okay, so here's the question in summary form then. So let's have a go at part 1. I'll just move part 2 and 3 out of the way for the moment. And we'll come to those in just a moment, just a little later. So let's get them down below. Okay. So, A is on L1. So we've got these two lines. Show that A is on L1. So part 1 here. To be minus 3, we've got minus 1 plus 2t needs to equal minus 3. So therefore move the 1 over. 2t there stays as is. Move that to plus 1. 1 minus 3 is minus 2. So that tells us then t is equal to minus 1, isn't it? Move the 2 from times to divide. So t equals minus 1. R is equal to, then let's put it in. The I vector will of course be minus 3. So it's minus 3i. And then the j, when t is minus 1, 2 minus 2 times 2 times 1, so it's 2 minus 2, which is 0. And then the k, 7 minus 1 is 6. So that's fine, because it's minus 3, 0, 6 is what we wanted. Okay, so A is on L1 and OA is perpendicular to L1. So A is on, so let's have a look at this then, let's see if it's perpendicular. So let's have a look at the dot product. So this is L1, 2, 2 and 1. 2i plus 2j plus k. Dot product of this is the directional vector of the line. This is OA then, isn't it? As a vector. No j's plus 6k. So that's what we've got here. So that equals minus 6 is the first component, plus 0, 0 times 2, and then it's plus 6, which equals 0. So we've shown that they're perpendicular. So let's turn our attention now to part 2. Oops. So I just try and get the section I want, which is not. I'm just going to do one more go. Try and take most of it if I can. So let's just take that down a little bit. Okay, so I just wanted to make one last observation here on this stuff. And just remark, so OA is perpendicular to L1 by the dot product property, or by virtue of the fact that since if the dot product is not, then cosine of the angle is 0. And that's by the dot product rule. Okay, I've just made that observation. So we got OA is perpendicular. So we got two lines here, L1 and L2. We've shown that, what have we shown so far? Show that A is on L1 and OA is perpendicular to L1. So we've shown that A is on L1. Let's put A there. And we've shown that O is here. And this vector is 90 degrees. So that's the picture we've got so far in our mind's eye. Show that the line through O, and let's stick to the actual paper. Show that the line through O and A intersects L2. And A intersects L2. Okay, so show that this line then through O and A, so this line here intersects L2, so I'm going to draw this line in now. There's the line through O and A. We want to show it intersects L2. So part 2 then. For the line OA, R is equal to, we could start from 0, couldn't we? Plus lambda times the directional vector OA. And that's minus 3, 0, 6, minus 3i, plus 0j, plus 6k. So there's OA then, as a line through A. L2 is up here, so I'm going to drag that down now, and use that in the question. So here we go, let's pull it down then. This is L2, and we want to show one is equal to the other. So let's have a look then. So for that to be the case, for these lines to intersect, then minus 3 lambda must equal 2 plus s. That's the first equation. The second one will be 0 is equal to 9 plus 3s. 2. Straight away we can see what s is here. S is minus 3 here, isn't it? When we move the 9 over to minus 9. And if we put minus 3 in here then, 2 minus 3 is minus 1. Minus 1 over minus 3 is a third, so lambda is a third. So we can just see that there. So I'm just going to write that down. And the third one, we need 6 lambda is equal to minus 4 minus 2s. 6 lambda is 2 is equal to minus 4 minus 2s is times 3, minus 3 is 6 plus 6, which is equal to 6 take 4 is 2. So lines do intersect then. So lines intersect. So we've shown that, and we've found the parameters. Given that the point of intersection in part 2 is B, find the ratio of OA to OB. So we need B then. So here we can put part 3. So what are the coordinates of B? Well, if we put lambda in here, a third minus a third is 3 times a third is 1 with a minus. Then it's 0 times lambda is 0. And then 6 times a third is 2. So there's B. So OB then, as a modulus, is equal to this squared, and this squared, all added up and square rooted. 4, 5. So square root 5. OA. Let's go back and get A. Okay, where's A? Part 1. Where is part 1? OA is minus 306, so OA here, let's just do it here, is equal to 9 and 36. 9 and 36 is 45, so that's square root 45. So let's just move that down then. Now we've looked at OA. And then we want the ratio of OA to BA, don't we? Oops. OA to BA. Okay, there's OA. And then BA. So we need BA now. So BA to a, which is a minus b basically. So let's get the coordinate of a. Shouldn't take too long now. Minus 3, 0, 6. So a is minus 3, 0, 6. So b to a is a vector then. Is minus 3 minus 1 is plus 1. So it's minus 2i. 0 take 0 is 0j. And 6 take away 2 is 4k. So that tells us what modulus of BA is, which is what we wanted in the first place rather than OB. 4 and 16 is 20, so it's root 20. So the ratio of, let's get it the right way around, OA to BA. So OA to BA then. The ratio of these distances, moduli, is root 45 to root 20. Okay, so this ratio here, this is 9/5, so it's 3 root 5. And this one is 2 root 5, isn't it? When we simplify that. So it's equivalent, the root 5's will cancel, and it's simply the ratio of 3 to 2.